Alright guys, we're going to go ahead and do some more practice of what we talked about yesterday. So that way we can reinforce and we work on getting better at practicing this. Okay, so the difference between these two, the first two examples in this case, is one has the exponent associated with the x, and the other has the exponent associated with the actual function. So in this first one, because it's associated with the x, before I even take the derivative, I can go ahead and bring that exponent out. So now I'm just taking 3 times the natural log of x. And when I take the derivative of that, it's a coefficient, times the derivative of ln of x, which is 1 over x. So my final answer is 3 over x. However, the second one, because it's to the entire function, I'm going to have to go ahead and use a chain rule. So chain rule tells me I bring that 6 down, keep the inside thing the same, reduce the power by 1, and then take it times the derivative of the inside. And then the derivative of ln to the x is just 1 over x. So we go ahead and simplify that guy. Everything in front goes on top, so I have 6 times the natural log of x all to the 5th, all over x. Okay. We're going to go ahead and talk about using that u substitution stuff, kind of like what we did yesterday. So I'm going to go ahead and let my u be whatever is on the inside. So I have 5x squared plus 7x. Oops. I meant to write 7. Come on. And then the derivative of that guy is 10x plus 7. And when I take the derivative, it's just the 10x plus 7 over the 5x squared plus 7x. And we got our answer. Okay, this one's a little bit more intensive because, as you notice, we have the whole thing quantity to the 4th. So we're going to have to do chain rule, but I want to go ahead and set up my inside part because I know I'm going to have to take the derivative of it. So my u in this case is going to be 8x cubed plus 5x. And the derivative of that guy is 24x squared plus 5. So, starting with that chain rule, we're going to bring that 4 down. Then we have the natural log of 8x cubed plus 5x, all to the 3rd, because we reduced by 1, times the derivative of the inside, which gives me that 24x squared plus 5, divided by 8x cubed plus 5x. Now with this one more step is I can go ahead and put the 4 together with one of the 2 terms out of my knee. There you go. Goodbye. So that being said, I can't put it with this guy because he's got this the cube. Since he's got this guy, I can't put him through. It's kind of a big like meh. But I can put the 4 with this guy because it's just a regular set of parentheses. So I have a whole number times a fraction, means the whole number just goes and multiplies through on top. So 24 times 4 is 96. So 96x squared plus 20. The denominator stays the same. So 8x cubed plus 5x times the natural log of 8x squared plus 5x. Excuse me, 8x cubed. I said squared. My bad. Okay, this one, you can use quotient rule, essentially, because it's a derivative. It's a, it is a fraction. Wow, that was so hard to say. You're going to want to do it because there's one like this on your homework. So for a quotient rule, to refresh our memory, it's low times the derivative of the top, and the derivative of natural log of x is 1x, 1 over x, minus the top times the derivative of the bottom. All over the bottom squared. And 3 squared is, excuse me, x cubed quantity squared means I multiply the 2 with the 3, which gives me the 6. Go ahead and reduce some stuff. I have 3 on top, 1 on bottom. This will give me an x squared. Minus, I personally, like to write the guys outside so I don't accidentally get them confused with the natural log, just like with sine. And there's my answer. This one we're going to go ahead and have to do a product rule with. So I have the first, which is 3x squared, times the derivative of the second, which is 1 over x, plus the second, which is natural log of x, times the derivative of the first, which is 6x, which gives me, well, I have 2 on top, 1 on bottom, so those cancel, so I'm left with 3x, plus 6x, natural log of x. Alright, there's your homework.